Okay, so now we're going to move on to LIDAR operations, kind of get into what I was talking about with the heading alignment. This would normally, of course, be done out in the field, but we'll kind of show as best we can through this to show you how do you operate the system and go through some of the lighting sequences and whatnot. Okay. So this is kind of just some general information. Of course, you're going to want to be operating as you would any drone flight with regional rules and whatnot. It's no different than any other flight, really. So it's just kind of some disclaimer. So we'll start with the base requirements for this section. It is important to consider this during the planning phase, because you need to know how you're going to get corrections to your LIDAR data. You should think about this before traveling out to the site if you can. All these systems are PPK solutions, so the GNSS signals are recorded by the sensor in flight and will be corrected later in software with the use of a base station that is also collecting GNSS signals, and it'll correct that. As opposed to RTK, where those corrections are they're applied in real time, hence the name. So we got post-processed kinematics versus real-time kinematics. So there are going to be three options for this. There's local base. So this is a physical base station that's set up on site before the mission starts. So that base is recording GNSS signals or data during the entire flight. And it should be within 12 miles of the survey. And then you can also use local core stations as bases as well, as long as they're recording at 1 hertz or 1 observation per second. So as long as it's within 12 miles, you probably have a little bit more of a range than that, but it's starting to get a little far away, and you're going to be losing a little accuracy as it gets farther. For subscription based, so that's for just go into this for subscription based customers, or if you're just using True Viewpoints, which you can if you have a purchase unit. You can use these other two options. So these are cloud-based services. They have some fee to them, just like any cloud-based software or processing tends to. So you can use Applanix SMARTBase. So what this does is it creates and I'll show you a few things on this here shortly. But what it does is it creates a Rhinex data set for your location by using multiple stations around your area. This does allow for a longer baseline, so further distance away from your flight area, because it is using multiple stations. Limitations for this, of course, include where these nodes in the network are, and we can look at the Applanix SMARTBase solution, and I'll do that here shortly. And we also have our article that kind of explains on the knowledge base that explains the pros and cons. I'll go over that here shortly as well. Actually, I'll go ahead and pull that up because it's a good place to show it. Legislative base options. This first article here, single base versus smart base versus PP-RTX. This kind of gives the pros and cons and some of the accuracy values for these types of applications. It kind of runs you through some of the general aspects, accuracies, whatnot, some of the restrictions, pros and cons, and some considerations. It's worth taking a look at if you're interested in any of those other solutions and not just using a base station. They're also useful for times when maybe your local base has malfunction, or you just don't have one at the time, or something goes wrong. Yeah, you can have these couple of options as, at least, if nothing else, as fallbacks. What I'll do now is, since I have this pulled up, I'll just pull up Applanix SMARTBase. So this is another account-driven interface. It is free. I'll just log into my account, and what we can do here is, if you can plan ahead and actually go see how you're if you planned on using this, how well it would work. Let me see. It's too far down. So we're over here. Go to my test site as before. It is let's use where we're at. So say we want to fly somewhere like in this area here. We can do a couple things. You can draw out a polygon of your flight area, or just a line. What I'm going to do, I'm just going to drop a marker here. And when I click this marker, what I can do is I can preview the SMARTBase. So this is kind of giving you a general idea of how your solution would be in this area. So you can see that after you click it, you get these options. You get this quality index. It kind of gives you the nearest stations, and you can see that it's using multiple base stations, in this case 6, to locate where I'm flying there. I can also pull the data set straight from here. I haven't personally done that, and you can use it kind of as you can pull it straight into Evo, like that. This kind of just gives you a general idea. I'll also mention, if I go on back onto here, look up SMARTBase, see some of where this could be an issue, where using this is an issue, and you may not be able to use it. Like I said, this is kind of mostly a United States or North American type application. However, there are, as you saw on the map, there are stations all around the world. This is what we mentioned with seeing if it's available. This gives you a bit more information. But if you notice on an application like this, where all the stations that are in this area are along a coast in a straight line, and it can't get around your flight area, you may have an issue there. You won't be able to, most likely won't be able to use it, or you won't get a good solution because it can't find enough stations around you to get that a good data set for you. That's kind of a general overview of SMARTBase. So last option, this is going to be the most expensive option, but is also the least accurate. But it is available anywhere, pretty much anywhere at all. Yeah, you can use this. So if you're in the middle of nowhere, we had one of our pilots fly in South Africa, and this was the option they had to use because there were no core stations, no Applanix SMARTBase they could use out there. So they used Centerport RTX, and you're able to get a solution. Like I said, it's the least accurate, but it is an option. So with these 3 options, it kind of gives you some fail safes if nothing else. Like I said, just kind of a general overview of those options. Like I said, these last 2 are used with what we call true viewpoints. Those can be purchased through us. I'm not exactly sure the conversion, but I know with SmartBase it's fairly, at least for some people, it's fairly affordable, and they use it quite often. But a lot of they recommended, and how we operate is with local base, setting up our base station. So with talking about that, we'll have to talk about the local base station requirements. That needs to be able to obtain coordinate observation in lat long, ellipsoid height in meters, L1, L2 support with a minimum of GPS and GLONASS. Also 1 Hertz interval, that's fairly important. Also, if you have a question, you have a base station you're not sure of, you can contact us with the model. We can check with Applanix and make sure that's supported. But most of those the major ones are, like Trimble, Topcon, Leica, those they're supported, but all the major antenna manufacturers are. Okay. So mission checklist. I'll briefly go through this, but it's not something I'm going to go through each individual step with, because it is a lot of, you already know the stuff for, at least for the drone side for the most part, or you should. I'll go through most of the TrueView stuff with the videos. I'll go through it as I go through the videos. Some things to note. Since the system is powered by its own battery, there are 2 power cycles, so the drone is and sensor can be powered on at different times. The TrueView is, at least in proximity mode, is a 1-button operation. You just turn it on, and it should be good to go until it's done collecting, and then you can turn it off. Of course, you have the readouts, kind of give you some data. You want to make sure that you leave the system on after the flight. You can't just immediately shut it down. There is some data that is transferred to that stick in post-flight. So there are no in-air commands required or at all possible to the system. So it is just you turn it on, it starts recording, and you fly and finish. And these heading alignment maneuvers are required, and I'll show you how to do those. Fairly simple. So this is the checklist. Everything in white is going to be drone related. Everything in green is our TrueView system. This is included in the hardware user guide, as well as in the documents for the training. But all our user guide, and you can find the user guide, of course, on our knowledge base and whatnot. But I'll go through this general checklist with the videos. Okay. So before the flight, what we'll want to do is, of course, you're gonna plug everything on. This is probably what might be best. What's going to be best to show is this video first. This is installing the system itself. So this is an M600, of course. You'll just fold out the antennas first on that aircraft. The newer antenna style is not this screw-in type. It's just it's a piece of aluminum that just sets in here. It's got a base that it just clicks into. That way it's removable. A little bit easier to fit in the case. And we'll be adding more videos, especially with like the M300 as we get them. We're kind of working on those now. Next, you'll want to fold out the arms, all 6 of them on this for this aircraft. Next up, just pull off the prop protectors and fold out all the antennas, or not antennas, sorry, props. So here, this is going to be, we're going to show 410, but it's very similar to all of our systems. So this is what's included in the kits. So you got the LIDAR system, control box. You got the LIDAR system here, control box, antenna, 2 batteries over here, as well as chargers for that. You'll screw on the antenna. You want to make sure this is on there pretty snug. There is a spacer built into the antenna mast that is compressible, so you're not going to hurt the antenna or the mast by screwing it in there pretty tight. You don't have to get it too tight, of course, but you want it on there pretty good. You'll next put your control box on the system, or on the top plate here. This is the older style, but it is pretty much the same. So mounting the system. So this is the rear of the aircraft here. At least the M600, you'll go on from the left side, and slide into the mount. You make sure that's loosened. Align that dovetail and slide in. You just kind of get that flush. You'll then tighten that knob down, get it nice and tight. Install your safety wire just around the aluminum frame and around the rails of the M600 itself, or whatever mounting kit you have. Then plug everything up. You've got 2 things to, you got 1 thing to screw in and another cord to plug in. So you screw on the antenna, and then plug in. We use an Ethernet cable to communicate with that control box. This just plugs straight in. You also plug it in on the control box side. You can then take the lens caps off of the cameras. You can install your battery. It only goes in one way. You can check the percentage on the back there. You can then plug in your UMS. It only goes in one way, or it can go either way since it's USB-C, but it only goes in one spot. And then that's the installation of, at least on M600. It's going to be fairly similar with all of our integration kits. They're going to be very, very similar. The mounting location will be the only thing that's different. So now we've got the system mounted on here. We're ready to go fly. So what we want to do when we're out there is, I don't even know if I want to. Let me see. Let me just watch. I think just play through the videos would be best. So pre-flight operations. So what we're going to want to do with this is we'll have everything mounted, ready to go. We'll move the aircraft to a safe launching point. Aircraft faced away from us, of course. You can then turn the system on by just flipping the switch in the battery cover. And then close the battery door. Now we can go to the control box and we should see a light pattern. And on the LCD, you'll see some messages and telling you kind of what it's doing. It'll blink all 3 yellow. This is kind of just initializing the system. It'll then go in through each individual light as it goes, starting with the battery. You'll see the battery starts blinking yellow. It'll then go green, or whatever, depending on the percentage. And then it'll tell you a percentage on the controller, on the LCD. It'll then typically go to the system light. And what it'll do is check to make sure the UMS is plugged in. If it's not, it'll tell you it's not plugged in. All you have to do is plug it in and press the cycle button, which on this one's a big green button, but it says green cycle. On the other one, you just press it and it'll continue on to its usual pattern. It'll then blink the GNSS light until it finds GNSS signal. It'll say getting location on the control box. It'll then start blinking the system light yellow. So this is saying the system is booting up, so it'll be connecting the cameras, the LIDAR, make sure all those are running correctly. Depending on how you have the aircraft operating, if you're operating in proximity mode, what it'll do after this is once it's ready, you'll see the light pattern change here shortly. It'll change to flashing green. And then on the control box, it'll say proximity mode active, so it's ready to go, ready to fly. If you're not in proximity mode, what you'll do is you'll get a solid yellow light, noting that it's ready to record. It should say on the control box as well. All you have to do is click that cycle button and it'll turn solid green and say it's recording. That's only if you have it not in proximity mode. If you have it in proximity mode, you're just good to fly right now and good to take it up. Let me see, it looks like I have two of the same video in here. Let me grab the heading alignment maneuver video really fast. Let's see, training. Actually, I think I might have it in here. Oh, there it is. Okay, so now you're ready to fly. What we're gonna want to do is typically what I'll do with the power on the drone, something I didn't mention is I'll either wait until the LIDAR is completely ready to go, or I'll wait till after the GNSS is acquired, then turn on the drone. You of course can turn it on beforehand, but it just kind of saves battery on the drone. But whenever you're ready to take off, you'll take off manually. I typically go up to my flying altitude. I'll just go straight up. I'll make sure I pick a safe distance to go, or a safe direction to go, over grass. Try not to go over buildings, water, people, whatnot. What you'll then want to do, once you got your safe direction, you'll go full throttle forward. You can count to like 4 seconds or up to 9 meters per second. As soon as you hit that 9 meters per second, you'll let go of the throttle completely and abruptly, let it come to a complete stop, as shown here. And then what you'll do is you'll turn it a couple degrees and then come straight back, full throttle, and up to 9 meters per second, let off completely, abrupt stop. Once it's settled, you can upload your mission plan, fly. And what you want to do when your mission plan's done, you can do this a couple different ways. You can let it return to home, but before it starts descending, take manual control. And by manual control, at least on DJI products, you can just flip the mode switch out of P mode into any of the others and back into P really fast or really quickly. And it don't have to be that quick, but flipping it in different modes will take manual control. It's just one of the quicker ways. You can also pause the mission on the screen if you want. You'll do the same exact thing with the heading alignment at the end and then proceed to land. So that's before and after each mission. The reason we do this is the way we process the solution is we do a forward processing of the flight, and we do a reverse processing of the flight and make sure those two solutions match up with each other. Okay. Now we'll kind of look at the control lights. Kind of briefly went over this, but we'll show this. So at the beginning of the flight, any flight or anytime you turn on the system, you'll have 3 blinking yellows regardless. Next one down, if we have an update, we have some explanation in the hardware guide how to update. That last light, the system light, will be white. I think it's more of a yellowish color nowadays. Next one down, checking battery, went over that. Third one, UMS is not recognized. So this is what I mentioned. If say the UMS is not plugged in, you'll get that flashing red system light. All you have to do is plug it in and press the button. Third is checking GNSS signal. Went over that. There's some more functionality to that GNSS light that I'll go over after this slide. Next one is if the unit's not in proximity mode after everything's booted up, after I had that yellow flashing, or that yellow flashing is checking the cameras or winding down, so it does have some variation to that. If you're not in proximity mode, you'll get that solid yellow. It's in standby mode. You're either ready to fly or it is finished winding down, so there's some conjunction to that depending on the mode you're operating in. Flashing green means proximity mode active, ready to take off. Red solid light, so that's a hard error. Typically with the cameras or hardware, what's best if you have this, you'll probably get an error message on the screen or something that gives you a little bit more information. Typically, Power Cycle will fix this, will fix these issues. You have a red flashing after everything's ready, so it's typically an issue with the cameras. You just want to check the SD cards or make sure they're installed, and then check the cables. There's 2 cables or a cable on each camera that connects them. You just want to make sure those connections are solid. This chart is in our hardware user guide. We do have these screens on all. This is a note saying that the readout is on the 600 series, but it is on all units now. So the other functionality of the GNSS light is this. Depending on the quality of satellites, before the sensor takes off and the number of satellites drop, it'll blink the system in the GNSS light for you, yellow. If after booting complete and before you take off the GNSS signal is lost, it'll flash red GNSS and yellow system. Now, if it's during the flight, if you at any point had completely lost GNSS signal at any time, you'll get a red solid GNSS. Doesn't mean you didn't. You could still have gotten it back in the flight, but it's just to let you know that you had signal loss in flight. If it's flashing red, that just means at some point your satellites drop below 4 at some point in flight, but it got it back before landing. This is just to let you know with the GNSS signals. Okay, I think that's most of operations.
So if something happens in flight that we lose connectivity or something stops recording, we'll be getting some of those flashing errors when the aircraft lands.
Yeah, if you get any error in flight, it'll tell you if it's GNSS related, it'll be the GNSS light. If it's system related, it'll be the system light. In another place, and it'll give you on that readout, it'll give you a little bit more information, as much as it can on that little screen. What I'll typically do if I have an issue is I'll go look at my CycleLog, and I'll show you that here in a bit, and you can get a little bit more information. Typically, Power Cycle fixes most of that things, but if it's in flight, That could be a number of things, you know, hardware related or GNSS related. If it's GNSS, it's a little hard to, you know, it's sometimes hard to track down because it could just be that you had bad satellite coverage at the time, or it could have been, even if you had lost satellite signal as soon as you took off, so maybe trees were covering it at some point. As long as you got it back, you'll be fine, and your cycle will be fine. But this is just kind of to give you extra information if something does happen.
Gotcha. Okay, but there's some indication if there was a problem during the flight.
Yeah. Yep.
We won't know it. We won't know it till it lands, but we'll know that we need to, something's going on and we need to check our data.
Yeah. And where I would go if I had an issue like that, like I said, I'll go CycleLog, and I'll show you that in a second. That's where you're gonna see what happened. Typically, and if the customer has an issue, what they'll do is they'll just call us in and we'll walk you through what we think, see if you think we need to refly or if we think you're good. A lot of the times, you're even if you get an issue, you can still process that data no problem. It just depends on what it is that happened. But yeah, you do have some indication on landing of if there was an issue. So this is the landing. So this is after the last hitting alignment maneuver and powering off. So this is kind of, I went over the light sequence of what's going to happen. So what we should see when we walk up to this is that the light is flashing yellow, noting that the wind down procedure is happening, and it should say on the screen winding down. Depending on how quickly you get up to it, and you'll see this video kind of cuts off at a solid yellow. It's not that quick typically. Unless you're not operating and if you're operating in that mode where it doesn't transfer the images. Typically what you'll see when you walk up to it is that it's transferring those camera and it'll give you a percentage on those images of what it's transferring. And then it'll transfer a TO4 file at some point and log data after the images. But it'll tell you, and as soon as it's done, it'll go that solid yellow and it should say flight complete, and then it should cut you back to the battery percentage. And that means that flight's complete. What you need to do now is to do another flight, you'd have the power cycle and just redo all the same steps as before. Typically after one of my flights, though, I'll data check it before I take off and fly another mission. And depending on what system you have, so this part here is derived more for the 410, but what I'll do is I'll show you a more general how I data check mine. What I'll do is, so let's say I plug the UMS into my computer. I've got my cycle folders. What I'll do is I'll go in here. You won't have this. This is using a data checker. You won't have that. You'll have these two folders, this flight and the system folder. I typically start with the system folder. You got a number of files in here. These are my observation files, so that won't be, that's my base observation files. Those won't be there on yours unless you put them there. And that's maybe a good place to say this. If you put them here, Evo will automatically recognize them, but you can also put them into Evo by pointing to it, but that's just kind of off course. But the first thing I'll check, I'll go into my CycleLog. I'll open it with Notepad++. This is going to be a wall of information. A lot of stuff that probably won't mean too much to you, but what I'll typically do, I'll just hit Control F. And the things you're looking for, I'll search warning or warn. It said I can't find anything. That's typical. Warnings, if you do find them, they're not always, they're usually not like complete failures, of course. They're not errors. So your data is probably fine. Usually a warning is something like if it took a picture and the exposure wasn't set right, it'll throw a warning. And that's not an issue if it retries and is successful. It's only an issue if that's an error and it can't redo it, but it'll throw that on the control box if it has an error. That's kind of at the beginning of the flight. I'll typically search error next, and nothing for error. As long as you don't have those two, you're usually good. That's kind of that quick check to see if you had any issues in the flight. You're welcome to scroll through these, take a look. It kind of tells you how many GPS or how many satellites you had at certain times, kind of gives you timestamps, some stuff that doesn't really an issue, and then you can see that I started flying here, and it gives you distance to home as well as some coordinates. Nothing too important to check after every flight, but I would just check for warnings and errors. If I don't have anything, what I'll typically move on to next, I'll go back into my flight folder. You see that you got a number of files here. You got your cameras and your laser. I'll typically check my laser first. I'll just click in here and look at the size of my file. We don't have a tool yet for the 515s and the 600s. We do have one for the 410 that can check this file. We are working on getting those, but as long as this size here is the reasonable size, I mean, as long as it's not like 100 kilobytes and you just did a 20-minute flight, this, like I'll say, this is a 515 doing a about a 9-10 minute flight. I get about 800 megabytes worth of a laser file. As long as this size sounds reasonable, it's typically close to a gig or more depending on the flight time and the sensor. With the 600, it's going to be a little less than this. This is probably going to be the highest number with the 515. But as long as that number sounds reasonable, you know your data is there. Typically, you can go check my cameras. I'll just click my camera. What I'll do is I'll view my images. You'll see I have an overexposed image here. This first one. This doesn't. I guess it doesn't throw a warning anymore. It throws a I don't think it only throws a warning if it can't fix it. But you'll notice you can look at all your images. I'll go in here. I'll take one. I'll open it up. Make sure it looks fairly clear. Make sure it's not fuzzy. Like this looks good. I'll typically then look at my bottom left to see how many images I have. So I have 242 items in here. So then all images, there is a extra file in here. I'll then go to my second camera. Do the same thing. Look at my images. I'll just pick one or two. Make sure it looks clear. It does. I'll check my item count. So we got 239. So as long as those are within a couple images, it's usually 2 or 3. The way we have the camera set up, one's going to take like 1 or 2 extra pictures on before it winds down. So that's completely normal. As long as one camera, doesn't have like 100 versus the other one having 200, it's not an issue. But that should give you a warning if it's that far off. Didn't mean to close that. But that's typically how I would field check this. This system file just has some flight information, nothing that you need to check during each flight. That's kind of the data process or the data check process for each sensor. No matter the sensor, I don't know if anybody is getting a 410 in today's class, but I'll throw the quick check in here just to show you. I think it's useful to at least know. So included with, at least with our 410s, you'll get a, and I think is in the training data. Let me check. If I go and open 2 of these, I'll open my QC. this data checker. So this is if you were using a 410, what you could do if you want to get a little bit more information about that laser. This is what I was talking about. We're working on getting for the other systems. Is I can go in here and I can actually drag my laser.bin file onto this batch file. What it'll do is it'll pull up the command prompt window that's, oh, this is, sorry, I grabbed the wrong file. I grabbed a 515. If you grab it, it's not gonna, let me grab a 410 flight real quick. Let's see. Okay. You can drag and drop this laser.bin on that data checker. What it'll do is it'll pull up this and it'll run through the number of minutes of how long that flight was. And what it'll do is generate a text file with a little bit more information on that data file, or on that laser file. So it can tell you here, or you can look at the file it produces. But you'll see here, what you want to check if you do have a 410 and you're looking at one of these, you want to make sure your motor spins counterclockwise. Typically doesn't change. I haven't seen, at least for as long as I've done these flights, I haven't seen a change. That's something that was an issue in the past. These timing anomalies at the beginning are benign. That's just how all these flights are. These aren't an issue. The only time these timing anomalies will be an issue is if they're in between this LIDAR start and LIDAR end time. It also is a thing that hasn't happened for quite some time with firmware fixes. What those do, as long as they're very small and they were in here, it wouldn't be an issue. But if they were like this 202 second, that's going to introduce a data gap. And I'll show this more on the slide. LIDAR begin. You want to make sure that's not more than 30 seconds. It typically isn't. This is all normal. Spin reversals, it'll tell you if you have any spin reversals. And you want to make sure you have that 100% of expected total seconds. So I'll go a little bit more in depth with the PowerPoint here. So this is where I said you can drag and drop it. Let's see. Like I said, you want to make sure there's no timing anomalies or spin reversals in there. No warning messages. What those will look like is something like this, where you can see that this is a couple issues here. It shows, you see that LIDAR began 330 seconds after the mission. So that means that whole 300 seconds that it was taking to start that LIDAR, it didn't record anything. We've kind of built into the firmware, if it has an issue with the LIDAR, it's got I think it's like a 30-second timer, and it'll throw an error if it isn't ready in that amount of time. Haven't seen it in a while though, because we've kind of fixed that with firmware. You can see that it gives warnings at the bottom. You can also see that there was a lot of spin reversals in this flight. It's also something that hasn't happened in a while. But this is some of those issues. But what it'll do now is if it is this right here. If you get that hard error, it may have detected that the LIDAR didn't start in the time that it expected it to, and it just requires a restart. Usually fixes it. You can see that there's a pretty large data gap here because of that start time. This is what a spin reversal would look like. You just get that fanning, like semicircle pattern. Like I said, I haven't seen it in a while, but it's just a note. This is what it'll look like if you have an anomaly in the middle of your flight that's more than a second, I'd say. You could, with the amount of density we have, usually if the anomaly is very short, it's not going to be an issue. But if it does get large, you can have a gap like this. Okay, I think that's any questions on any of this?
So we wouldn't know that until we check the data, or is that part of our field check that we should be completing?
So these issues, I'm just kind of letting you know to be aware of them. You'll see these as well, with the 410 you can check these. With the other ones, don't think I've only ever seen these issues with 410s, and that was on it's been quite a few firmwares ago, and this is kind of something we've addressed with firmware it's been over 6 months probably since we've seen stuff like this. It's just kind of something to be aware of. With the 515-600, I have not seen it at all, and not with the 410 lately. But yeah, with the 410, you could see it in the laser. With this check tool. With the 600 and the 515s, not necessarily, I guess. You're able to, as long as you roam your licenses or have a VPN, you could potentially data process up to a point cloud in the field. I mean, the processing to a point cloud typically is, you'll see how fast it is later, but you could get that done in like 15-20 minutes, depending on if you're using a subscription. It might be a little bit longer because it uses the cloud processing. But if you have a purchase system and you got that local, you can process your up to a point cloud out in the field if you wanted to. But like I said, these issues are just kind of for reference. Haven't seen them in a very long time. But yeah, like you said, you probably, if it's not a 410, you probably wouldn't notice this until you're flying, or after you process the data, which we're working on a tool to check these, kind of in the process of doing that. Any other questions about any of the data checks or the heading alignment, light patterns, any of that? Okay. So what I'll do now, want to make sure did everybody that wants to follow along with the Evo today get that? I know somebody had an issue with the license. Did anybody else have an issue with licensing or pause back or anything? I think we had one with at least an issue. What I'll just go ahead and do is I got Evo pulled up, and what I want to do for the license, so you can grab, depending on how you have the firewall set up, I'd probably just, if you're having issues with the one that needs ports open, just grab